Thank you for joining me. This video is going to detail how to use a 30-inch by 30-inch X-carve CNC to uh, tile and make a very large precision cut on a piece of aluminum. In this case, an aircraft skin, about a 10-foot long piece. So it's a technique called tiling, and so I'm going to walk through the process of doing that. If you Uh, some of the things I won't cover in this will be some basic things on how to use AutoCAD Fusion and the CNC itself. I cover that in a separate video that's basically precision aluminum routing with the CNC router in your garage. There's another YouTube video that shows that. It's also on my scratchbuild.net. So this is going to focus on the techniques required to tile it over a big piece. So what we're looking at is a 100x speed up of the routing and the drilling of this large skin that I'm doing for my aircraft. Doing drilling and routing. And I have taken the baseboard off the CNC and just used the framework of the CNC, and then I clamp it down on top of the material and am able to do a portion of the skin at a time. And so this presentation, the next 10 minutes or so, I'm going to go over the steps I use to get the command set up to do these pieces and how I got accuracy from moving from one piece to the next so that this is one large piece. Now that you've seen the end product we're trying to tile across, let's figure out how we're going to set that up in AutoCAD Fusion. Okay, so we're in Fusion here, and we're looking at our looking at the skin that you just saw being CNC'd and cut, and you see the skin, and then you also kind of see this little strip that I have on the bottom, and I made this just to kind of make it easier to see. But basically, what this strip is, I've drawn in is a small 1-inch strip that has a hole every 30 inches marked, a simple hole every 30 inches, and I'm going to use that as my reference, my 0, 0 reference. I'll describe that more in the slides, but basically, hard to see if this, but you have a 0-inch, 30-inch here, 90-inch, 120 inches. So each of those are going to be my 0, 0, XY reference point when I do the CNC routing and the drilling. So the thing that makes us, we draw out the part the same way we did with other small parts. This is full scale. And then when we go into CAM here, we're actually going to have we're going to have multiple setups. I'm going to start with the one setup here, minimize some of these other ones so you can see. So when I turn up setup 1, remember in the CAM portion, when we watched the other video, you set up how big your workpiece is. And so what I'm going to do is just pretend like my workpiece is 30 inches by 30 inches. You can see that the corners center on these reference holes, the 0 and the 0,30 reference hole. And this is going to basically show where the material is going to get cut out. So I've set that workspace up. And if you right click this, well, there we go. If I double click it, stock. Here you can see a 30-inch width. And that's basically, I've set by a 30-inch by 30-inch width, and my height is still 25, so the material is the same thickness. But that's the real trick here, is setting up the workspace to be the space that you're going to cover in that one CNC motion before you move the whole CNC machine. And then, of course, I set up standard contour paths. These are cut path, 2D contour path, and then the pilot pull path. And you can see I'm just basically, when you select those contours, it knows that it's going to just do the part that's within the that workspace. So you can see that's our first tiling section. Then we go to the second tiling section. We zoom out a little bit, and then we'll see our next thing. Here's our next contour pass, right? When we're in the second tile, we click on that. You can see that it's going to do a cut here, and then a cut on the bottom. This time, in this case, I did 2 cuts, but I didn't really need to. I did a cut, and I came in a little closer. And then, of course, the pilot holes. So now, we zoom back out here. To do this whole part, we're able to do it as we kind of click through the tiles. So here's the first tile, second tile, third tile, fourth tile, and I have basically G-code files for both the routing pass and the drilling pass. So that's pretty much it. Pretty straightforward. So let's go back to PowerPoint here for a second. Some other tips that are important besides how to do the cam part. I've got this big piece of metal on my workbench, and you need to make sure that X and Y are perpendicular. So in my case, X-axis is along the horizontal here, Y-axis is going into the workbench, and Z, of course, is going up. So what I found that was useful is to take a square laser, this device over here, that shoots out 2 lasers perpendicular to each other. And that's going to allow me to keep, when I put some marker spots, it'll keep my horizontal and vertical square with each other. So I'm going to put a marker spot up here to square my CNC, because the CNC is now a little flexible. I don't have a baseboard on it. I can move it. It has a little bit of flex. The trick here is this X-axis has got to stay, straight over 10 feet. So the laser really helps with that, as opposed to like a tape measure or something, or a long straight ruler. Laser, I can get real precise on putting a mark. Here's the laser line. You can see, using a fine point Sharpie, I've marked off. This is a little thicker, but I knew where right here in the center is where my reference point is. So I set the laser at 0, 0 for the entire piece, and then I mark 0, 0, then 30 inches over, 60 inches over, 90 inches over, 120 inches over along the X-axis, right? So I've got all my markers. And then on the Y-axis, I move the square laser to each of those 30-inch reference points to put a 30-inch, to put a reference out for my Y-axis so I can clamp down my CNC properly. Here's a better picture of that. Basically, you need 3 points for each CNC alignment. Your 0, 0 here, your 30, 0, so 30 inches on the 0, and 0Y, and then your 0X, 30Y out here, so that I can make sure that when I move the router, it's going to be square. So here's 0, 0, here's 30, 0, here's 60, 0. There's your 30-inch over there that I want to mark. So I just make a line up there so that when I move the drill, you see all the reference points here. When I move the drill, when I put the CNC down, then I'm going to move, I'm going to move the, I've got the drill bit in there. I'm going to move it to 0, 0 on my universal G-code sender, right? And then try to get it lined up and then kind of clamp down. This big metal here is a clamp. Clamping it down to secure it to the table. Of course, my material is clamped down too. So I'm going to clamp it down just a little bit. I move to, so what we just saw with the 0, 0 over here, then I move on my universal G-coder, I manually jog the router over 30 inches, right? I jog it to the, it's actually 30, 0 position. And then I clamp here. I've got another clamp right here. So I'm clamping the CNC. You see the black metal. I'm clamping those 2 down so that that stays aligned in that axis, right over that point. I jog back to 0, 0. As you move this around, you have to kind of tweak it a little bit to get it so that it stays, when you move from 0 to 0 to 30, 0, that it does line up both times. And then I tighten down. Then what I've done here is I've moved out to the 30-inch position in the Y-axis. And this black, this y-axis beam, it can flex now that I don't have a baseboard holding it in place. And so I'll move it out here and get this length, and then I'll clamp down the y-axis. That's a third. In this picture, you can see a little better. Actually, the clamp's not on there. You'll see it in another picture. I've got clamp here, and then when I was out here, I would use another clamp on this axis, and you'll see it in some of the other pictures. I use like a 2x4 to hold it down and clamp at the edge of the board because this is a 4-foot table. The other thing you got to do is measure to ensure that the distance travel is accurate across long distances. I had trouble with this at first with this router in that this is belt driven, and it's not a real scientific process to tightening the belt. So if you tighten the belt too much, which I initially had done, it had gone more than 30 inches. The other thing I learned about was that you can actually set in using the Universal G-Code Center, you can manually set how many steps the stepper motor takes to travel certain distances. I'll try to put some notes on my website about that, but I recently learned about that, and I think that's a way to really calibrate down that once you've got your belts tight, that you're moving that actual distance. So you, out of the box, it wasn't quite precise. I would get out of the box, I kind of got, in one axis, I think I got about a 1/16 of an inch. It would travel an extra 1/16 of an inch over that entire distance. And the other axis, I think it was almost 1/8 of an inch that it would travel extra over the distance, so too far, right? And you really want the precision. So in the video that you saw, I got by that by loosening the belt a little bit and still getting what I needed. But the next skin I do, I'm going to go and tighten the belts up to kind of the proper tightness, and then I'm going to calibrate it by adjusting manually in G-Code Sender what the step value is to move certain distances. And that's it. And so thank you again. If you didn't watch the first video and you're interested in some of the basics, this was more of an advanced session on tiling, but I go through step by step on how to draw a part, how to do the cam, how to do the CNC, the G-Code Sender, so you can start from scratch and make a part. So that's in the other video. It's about an hour long, but this is just focused kind of on the tiling. So thanks a lot, and I hope you enjoyed.